Hey space freaks, ever been told that after Neptune there's just nothing? Well, that's a total lie. Way out there, there's a colossal cosmic donut of ice, stretching from 30 to 50 times the Earth-Sun distance. That's 30 to 50 astronomical units. This thing is 20 times wider and way more massive than the asteroid belt. It's packed with over 100,000 icy bodies bigger than 100 kilometers across, all made of frozen methane, water, and ammonia. It's the home of dwarf planets like Pluto and Eris, ancient relics from 4.6 billion years ago. Today, we're diving into its full, real history, mapping this crazy place and meeting its superstars and biggest mysteries. Subscribe or I'll hurl a Kuiper Belt object right at you. Let's rewind for an epic history lesson. Back in 1930, right after Pluto was found, astronomers like Leonard and Leuschner were like, hold on, there's gotta be more stuff out there. Then in 1943, Kenneth Edgeworth predicted a reservoir of countless small bodies, which could explain where our short-period comets come from. Fast forward to 1951, Gerard Kuiper speculated about a similar disk, but he thought it would have been scattered away by now. Ironically, the belt got named after him. The real breakthrough came in 1980. A Uruguayan genius named Julio Fernandez crunched the numbers and predicted a belt from 35 to 50 AU was needed to supply those short-period comets, the ones that visit us every 200 years or less. He figured it had to be 600 times more massive than the Oort cloud to work. Then, in 1988, simulations by Duncan, Quinn and Tremaine confirmed it. Bingo! The Kuiper Belt was officially named. But seeing is believing, right? In 1992, after 5 long years of scanning the skies with a CCD camera on Mauna Kea, David Jewett and Jane Liu finally found the first object after Pluto, 1992 QB1, now called Albion. And since then, we've found over 3,000 Kuiper Belt objects, with more than 2,000 of those discovered in just the last 20 years. It went from a wild hypothesis to a confirmed cosmic dumpster, kind of like your fridge after a big party. So what are the ingredients for this cosmic ice party? Let's find out. Ready to dive into the cosmic freezer at the edge of our solar system? Let's talk about the Kuiper Belt's origin story. Picture this. 4.6 billion years ago, our solar system was just a swirling cloud of gas and dust called the solar nebula. Out in the chilly suburbs, volatile ices like water, methane, and ammonia froze solid. We're talking temperatures between minus 220 and minus 240 degrees Celsius. Brrr, solar radiation zapped these ices, creating complex organic molecules called tholins. Some are reddish, like a cosmic pizza left in the oven too long, while others are blue. And get this, the Kuiper Belt was originally 20 to 200 times more massive than the asteroid belt. So where did all that stuff go? Enter the NICE model, a wild theory from 2005. It suggests that Jupiter and Saturn got into a gravitational dance, flinging Neptune outwards from about 25 to 30 astronomical units from the Sun. As Neptune bulldozed its way through the primordial disk of icy bodies, it scattered them everywhere. This created the Kuiper Belt we see today, and the even more distant scattered disk, which is the source of many short-period comets. Some of these scattered objects, called centaurs, even wander in closer to the Sun. Basically, the early outer solar system was a chaotic mess where the giant planets dumped their leftovers like a teenager stuffing dirty socks under the bed. And this all leads to a huge mystery called the Kuiper Cliff at 50 AU, where objects just seem to disappear. Spooky. Alright, let's break down the cosmic traffic out there. The Kuiper Belt isn't just one big ring of ice, it's a super complex neighborhood. First up you have the cold classicals. These guys are the calm residents, chilling in nearly circular orbits between 42 and 48 AU. They make up about 2/3 of the belt's population. Then you have the hot classicals. Don't let the name fool you. They're still freezing, but their orbits are way more tilted and stretched out. They're the excited, energetic neighbors. Next are the resonants, locked in a gravitational rhythm with Neptune. The most famous are the Plutinos, including Pluto itself, which orbit the Sun twice, for every 3 times Neptune does. They are stuck in a perfect 2.3 orbital dance. About a third of all known Trans-Neptunian objects are in these resonant patterns. And finally, you have the scattered disk objects, like Eris, on hugely eccentric orbits that can take them over 100 AU away, all thanks to Neptune's gravitational kicks. It's a chaotic ice highway out there, with billions of objects zipping around, thankfully with no speed cameras. Alright, let's meet the stars of the Kuiper Belt, the iconic objects that redefine our solar system. First up, Pluto, the dethroned king with some serious family drama. At 23 E76 kilometers across, it orbits the Sun every 248 years. It's tiny, just a fraction of Earth's mass, but it has a surprisingly complex family of 5 moons, including its giant partner Charon, which makes them a binary system. Pluto even has a thin nitrogen atmosphere, a massive 1,000-kilometer wide nitrogen heart on its surface, and water ice mountains that are taller than the Rockies. We got these amazing details from the New Horizons mission back in 2015. Then there's Eris, the jealous chubby one that actually eclipsed Pluto in mass back in 2005, sparking the whole dwarf planet debate. It's incredibly reflective, almost like fresh snow, and has a moon named Haumea. It travels on a wild, scattered orbit that takes it nearly 100 times farther from the Sun than Earth is. Next, meet Haumea, the spinning rugby ball nut. This oddly shaped world spins so fast a day lasts less than 4 hours, likely due to a massive ancient collision. It even has its own ring system made of water ice, discovered in 2017, plus 2 little moons. And we can't forget Make, the bright emo methanite. It's a bit smaller, glows with a reddish tint, thanks to frozen methane on its surface, and is super bright. It's a lonely world, with no permanent moon discovered so far. There's also Quar, a mid-sized probe discovered in 2002 with its moon Waywat. And Sedna, the true lone wanderer, whose mind-boggling 11,000-year orbit takes it so far out it might be a visitor from the inner Oort cloud. But perhaps the most bizarre is Arrokoth, the cosmic grandma snowman. Visited by New Horizons in 2019, this primitive reddish object looks like 2 pancakes stuck together. It's a contact binary, a pristine relic from the dawn of the solar system. And the list goes on. We've got Orcus, Gong, a whole frozen freak squad out there. In fact, about 20% of these objects are in binary pairs. Some scientists even think Saturn's moon, Phoebe, and Neptune's moon Triton were originally from here. So how did this chaotic neighborhood get organized? Well, it's all about dynamics. Neptune's gravity captured many objects into stable, resonant orbits while scattering others into the wild. The famous Nice model helps explain how these giant planets shuffled around and stabilized the whole system. The strange elongated orbits of objects like Sedna have led some astronomers like Batygin and Brown to hypothesize the existence of a hidden Planet 9, a massive world, maybe 5 to 10 times the mass of Earth, lurking hundreds of astronomical units away. But why should we care about this distant, icy donut? Because the Kuiper Belt is a treasure trove. It's the source of most short-period comets, which may have delivered water and organic molecules, the ingredients for life, to the early Earth. It's a time capsule, holding the pure, original mixture of our solar system. Missions like New Horizons gave us our first close-up look, and future observatories like the Rubin Observatory will discover thousands more. Each discovery is a key to understanding how planets form and unlocking the universe's secret recipe. The Kuiper Belt, a historic donut that eats old myths for breakfast. So which object is your favorite? The dramatic Eris or the quirky Arrokoth? Let me know in the comments. And don't forget to like and share. Next time, we're going even further out to the Oort cloud, full throttle to the stars. Thanks for watching.